So when they're given x is equal to -2 minus root 3i, and then question asks to find the value of this. So you can always substitute x in this and then simplify. But instead of that, if you could eliminate I from this expression, that means you write x plus 2 equal to minus root 3i, and the squaring on both sides. So the x square plus 4x plus 4 equal to 3i square. So basically x square plus 4x minus 3 becomes plus 3 plus 7 equal to 0. We call that as equation 1. And you can try to get this expression one by one. That means equation 1 is multiplied with 2x square will give us 4x power 4 plus 8x cube plus 14x square. Now you need 5x cube and you have 8x cube. So you need minus 3x cube. So the one equation multiply with minus 3x. So the minus 3x cube, of course this is equal to 0. So minus 3x cube minus 12x square minus 21x equal to 0. And then like we need 7x square. This is already 2x square and we need 5x square. So multiply with 5. So the 5x square plus 20x plus 35 equals 0. We add all of them. 4x power 4 plus 5x cube plus 7x square minus x plus 35 equal to 0. But you want 41, just add 6 on both sides. So the answer is just 6. They're asking us to find the value of p such that the difference of the roots of this equation is 2. You let alpha and beta be the roots of this equation. Then alpha plus beta equal to minus of minus p, which is p. And alpha beta equal to c by a, which is 8. And alpha minus beta modulus is given as 2. Now using this, you need to get the p-value. So consider the relation between these, alpha plus beta the whole square minus alpha minus beta the whole square equal to 4 alpha beta. If you use this relation, this is p square minus 2 square equal to 4 into 8. So the p square equal to 32 plus 4, 36. So the p equal to the plus minus 6. So find the value of a such that the sum of the squares of the roots of this equation is least. Let alpha beta be the roots. Then automatically alpha plus beta equal to minus of minus a minus 2 and alpha beta equal to minus of a plus 1. And value of a such that the sum of the squares of the roots of the equation. So the sum of the squares is alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. Alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. Sum of the squares is the asked. And then the value of a such that this is least. So first let us calculate this. A minus 2 the whole square minus 2 into minus of a plus 1, which is a square minus 4a plus 4 minus into minus plus 2a plus 2. So a square minus 2a plus 6 plus 6 is plus 1 plus 5, which is equal to a minus 1 the whole square plus 5. So this value is least. The least value is least, and this value is least when a equal to 1. When a equal to 1, this will be 0 and then this will be 5. Any other value of a, this will be more than 5. So this is least when a equal to 5. They ain't ask the least value of alpha square plus beta square. They ask the value of a for which this expression is least, that is a equal to 1. The 14th one, they're asking us to find the value of k for which this equation is true. Basically, you calculate the LHS and get the value of RHS in terms of this into some number and find out that number. So for this kind of calculation, mod z whole square, you can't use like just a minus b whole square formula because the modulus is there. That's why we are going to use this formula, the mod z square equal to z into z bar. If you use this formula, then the calculation will be easy. So the LHS, the entire thing is a complex number modulus whole square. So the first complex number into the conjugate of the same complex number 1 minus z1 bar z2 the whole bar minus z1 minus z2 into z1 minus z2 the whole bar. So now if you simplify this, 1 minus z1 bar minus z1 bar into z2 and conjugate of first factor minus second, first complex number minus second number is conjugate of the first one minus conjugate of second one. Conjugate of 1 is 1 itself, and conjugate of this, okay, let us write the conjugate of 1 also. Next step we can write. So conjugate can be separated for both the terms, and this is z1 minus z2. Here also conjugate can be separated for both terms, z1 minus z2 conjugate. And now if you simplify this 1 minus z1 bar and z2, conjugate of 1 is 1 itself. For any real number, the conjugate is number itself. This is conjugate if you separate for both. Z1 bar whole bar will be Z1 into Z2 bar minus, now you can open the bracket here, Z1 into Z1 bar minus Z1 into Z2 bar minus Z2 into Z1 bar minus minus plus Z2 into Z2 bar. 1 into 1 is 1 minus Z1 into Z2 bar minus Z1 bar into Z2 plus Z1 bar into Z1, Z2 bar into Z2 minus this is mod Z1 square. Z1 into Z1 bar is mod Z1 square, and this one is minus Z1 minus plus Z1 Z2 bar minus plus Z2 Z1 bar plus mod Z2 the whole square, And if you see that Z1, Z2 bar with minus and plus get cancelled, Z1 bar, Z2 with minus and plus get cancelled, and it is 1 minus, this is mod Z1 square, mod Z2 square, and then minus Z1 square, mod Z1 square, plus mod Z2 square. So from these two, you can take mod Z1 square common, and these two can be written together. The first and last can be written together. 1 plus mod Z2 the square minus mod Z1 square take common. So 1 plus mod Z2 square equal to, and then 1 plus mod Z2 square if you take common. So 1 minus mod Z1 square, and Z1 square taken common. But, so if you take these two common and then these two minus Z1 square. I think I made a sign mistake here. This is minus. And this is also minus. Then what you need to do? Then you need to take this one is plus. Yeah. So then this becomes minus. And if you take minus mod Z1 square, so this becomes 1 minus mod Z2 square. So then 1 minus mod Z2 square if you take common, you get 1 minus mod Z1 square. So you got 1 into that. So therefore k equal to 1. Okay. What they're given Z1, Z2 both satisfies this equation. That's what they told. So let us simplify this equation with Z equal to x plus iy. If Z equal to x plus iy, then Z plus Z bar equal to 2 mod Z minus 1 implies x plus iy plus x minus iy is 2x. Is 2 times of modulus of x plus iy minus 1. So this is what the modulus. If you simplify this, x square equal to x square minus 2x plus 1 plus y square. So the x square get cancelled, 2x minus 1 equal to y square. Now if z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2, as both z1 z2 satisfy this equation, 2x1 minus 1 equal to y1 square and 2x2 minus 1 equal to y2 square. Now the question asked is another information given is argument of z1 minus z2 equal to pi by 4. So let us focus on the other information also. If you focus on the other information, z1 minus z2 equal to x1 minus x2 plus I into y1 minus y2. So then because they are given argument of z1 minus z2 is pi by 4. So the tangent of argument tan pi by 4 equal to the y by x, y1 minus y2 by x1 minus x2. That implies tan pi by 4 is 1. x1 minus x2 equal to y1 minus y2. The question asked is imaginary part of z1, z2. So what is the meaning of imaginary part of Z1, Z2? That also we need to find out and then keep it aside. So Z1 plus Z2 imaginary part is equal to the same thing will come with plus between them and imaginary part is y1 plus y2 equal to what? So to get this information, and you have one information and another information in x1 y1 y1 x2 y2. So to make use of this information x1 minus x2, if we call this as equation 1 and this is equation 2, do 1 minus 2. That implies 2 times of x1 minus x2. The minus 1 would get cancelled. Y1 square minus y2 square. That implies x1 minus x2 is y1 minus y2. So the 2 times of y1 minus y2 equal to y1 minus y2 into y1 plus y2. So if we cancel that y1 minus y2 on both sides, y1 plus y2 equal to 2. And that's what we are looking for. And your answer, imaginary part of z1 plus z2 equal to 2. So the real value of a for which this complex number is a real one. That means purely a real complex number. So first let us convert this into a plus ib form. This is filling the blanks type person. So the 3 times of I cube is minus I and I square is minus 1 plus 1 minus a into I plus 5. So this the 2a plus 5 2a plus 5 plus I into 1 minus a minus 3, so which is equal to the 2a plus 5 plus I into minus a minus 2. So this complex number should be purely real. So it's possible when the imaginary part is 0. As purely real, like for real complex number, minus a minus 2 should be equal to 0. And the a value should be equal to minus 2. So we have modulus and argument form of a complex number. Any complex number z equal to r cos theta plus I sin theta, where r is equal to the modulus of the complex number and theta equal to the argument of the complex number. Now you have both. Modulus is 2 and argument is pi by 4. And if you simplify this, 2 times of cos pi by 4 is 1 by root 2 plus I times 1 by root 2. You just open the bracket, 1 by root 2 you take common. It will be root 2 or root 2 plus I root 2. And this is the answer, or root 2 you can take common and root 2 into 1 plus I you can write. Both are fine. So z satisfying argument of z equal to pi by 3 is if z equal to x plus iy, then and theta is argument, then tan theta equal to y by x. So if you use that logic for this complex number, the tan of the argument equal to y by x. So the tan of argument pi by 3 equal to y by x. So the tan pi by 3 is root 3. So the y equal to root 3x. That's it. That's the locus. So the value of this where n belongs to n is the question asked. And you can write this minus root 1 as I. So it's minus I whole power 4n minus 3. And 4n minus 3 is an odd number. So the minus 1 power, okay, you can write it separately, minus 1 power 4n minus 3 and I power 4n and I power minus 3. So this is minus 1 and I power 4 is 1, 1 power n is 1, this is 1 and this is 1 by I cube. 1 by I cube can be multiplied and divided with I and denominator is 1. So it's minus I and that's the answer. The question asked is to find the conjugate of this. There are two ways of doing it. First you find the conjugate and then simplify, or first you simplify and then get the conjugate. Any method is fine. So if you try to simplify it and given complex number equal to this and then 1 minus I you multiply in numerator and denominator. Numerator is 1 minus I whole square, 1 square plus I square minus 2I by 1 square plus 1 square. 1 and minus 1 cancel. So minus 2I by 2, which is equal to minus I. So this is what the given complex number. The problem with this method is after converting that into simple form, we'll forget to find the conjugate. That is the important thing like that you need to remember. Now, therefore, the conjugate equal to 0 minus I conjugate is 0 plus I. So I is the answer. So a complex number belongs to Q3, then its conjugate belongs to. If you know the geometrical meaning of conjugate of a complex number, so the Q3 means the complex number is here. Its conjugate is a reflection of that with respect to the y-axis, I mean x-axis. So the conjugate, if it is Z, which belongs to Q3, and its conjugate Z bar belongs to Q2, the answer is Q2. So they are given 2 plus I into 2 plus 2I, 2 plus 3I, and so on. 2 plus Ni equal to x plus Iy. They're asking us to find the value of this. If you observe the relation between the given complex numbers product and then the given expression that we need to find. So this 5 is the modulus of this expression. And this 8 is the, not exactly the modulus, the square of the modulus of this expression. And this is the square of the modulus of this expression. And this is the square of the modulus of this expression. And this is the square of the modulus of this expression. So if you made that observation, then your job will be easy. So to take the modulus on both sides for the given 2 plus 2i and 2 plus 3i and so on 2 plus ni and equal to the modulus of x plus iy. And we have a property mod z1 z2 equal mod z1 into mod z2. So the separation also you do. You write to 2 plus I the modulus into 2 plus 2i the modulus into 2 plus 3i the modulus and so on 2 plus ni equal to mod x plus iy. So this is under root 2 square 4 plus 1 under root 4 plus 4 under root 4 plus 9 and so on under root 4 plus n square equal to under root x square plus y square. But we want the square of LHS, so squaring on both sides. So this will be 5 into 8 into 13 into and so on into 4 plus n square equal to x square plus y square. So true or false questions. Multiplication by I rotates a complex number through 90 degrees. To understand this, you need to know the Euler form of a complex number or the polar form. So Z equal to R cos theta plus I sin theta, if you consider. And if you know the Euler's form, R equal to e power I theta is the Euler's form of this complex number. The cos theta plus I sin theta can be written as e power I theta. Now if you multiply Z with I, Z into I, equal to r into e power I theta into I. The polar form of I equal to 0 plus I into 1, which is equal to cos pi by 2 plus I sine pi by 2, which is equal to e power I pi by 2. So when you multiply, then it will be e power I pi by 2 multiplied. So then r becomes r into e power I theta plus pi by 2. So the argument of the complex number after multiplying with theta, suppose this is theta and this is z equal to e power r e power I theta. By multiplying with I, so the z will go here. This is zi. So the argument of zi will be theta plus pi by 2 and the modulus will remain the same. That's why the multiplication by I rotates the complex number through 90 degrees anti-clockwise is a true statement. The statement the complex number cos theta plus I sin theta can be written as can be 0 for some theta is a false statement. The reason is we have the polar form r e power I theta only for non-zero complex numbers. For this to be 0, it should be exactly 0. Exactly 0 complex number if we take and you will not have a argument for that. So argument is not 0 for it. So that is the only complex number. 0 is the only complex number which doesn't have the argument and it doesn't have the polar form of it, cos theta plus I sin theta. So as 0 equal to 0 plus I0 cannot be in polar form. So no theta such that cos theta plus I sin theta equal to 0. Basically, cos theta, sin theta both should be zeros at a time. It is not possible. Both cos theta and sin theta being 0 at a time is not possible. A complex number is equal to its conjugate, then complex number lies on imaginary axis, that is y-axis, is a false statement because complex number is equal to its conjugate, the reflection of that with respect to x-axis itself, only if it lies on the x-axis. If it lies on the y-axis, the conjugate of it is the negative of it. Basically, z equal to z bar implies z lie on x-axis, which is called real axis. If z equal to minus z bar, then z lies on y-axis, which is imaginary axis. If it is given as z equal to minus z bar or given here as x-axis, then that statement would be true because they are given opposite, so that's why the statement is false. Argument of z1 z2 equal to the argument of z1 plus argument of z2. So if you use that property and you can extend this for more than two complex numbers. So here argument of z equal to the argument of 1 plus I root 3 plus argument of 1 plus I plus argument of cos theta plus I sin theta. So it's very clear that this lies in the first quadrant, and for this suppose the argument of this is theta 1 and this is theta 2 if we call them. So the tan theta 1 equal to y by x root 3. So theta 1 equal to pi by 3. And here tan theta 2 equal to 1 by 1, 1. Theta 2 equal to pi by 4. So which is equal to pi by 3 plus pi by 4 plus theta, which is 12. And 4 what is it, 4 times 4 pi plus this is 3 pi plus theta, which is equal to 7 pi by 12 plus theta. So it is true. What they are given is true. So to verify this result, let us take z equal to x plus iy. Then this modulus of this is x plus 1 plus iy less than x minus 1 plus iy. So because the modulus you can square on both sides, then what it becomes, x plus 1 the whole square plus y square is less than x minus 1 the whole square plus y square. The y square get cancelled on both sides. And x square plus 2x plus 1 is less than x square minus 2x plus 1. So the 4x is less than 0 and x less than 0. So what you got, x less than 0 means it's one side of the y-axis. So this full region, so this inequality represents all the points for which x is negative. So this is basically one half plane, but they told that it is interior of the circle. If it is interior of the circle, then you should get the region represented by this inequality like this. That means you should get some, so x minus 2 the whole square plus y minus 5 the whole square is less than or equal to 7 square or something like that. Some circle equation you should get, and less than or equal to you should get. Then that represents the interior of the circle. This may not be 2, 5. This can be zeros also. Some of them can be zeros also, like that, like that. Any circle, but the interior, if it represents, then that this statement will be true. But we got this representing half plane, so it is a false statement. So they're given Z1, Z2, Z3 are in AP. That means Z2 equal to Z1 plus Z3 by 2. So the middle sum of the average of the first and last is equal to second one. So then automatically you get that the 2 Z2 equal to Z1 plus Z3. So this is possible only if Z1, Z2, Z3 are collinear. If they are lying in the same line, then only it is possible. So if they are lying on the same line, they can't be on a circle. If you take any 3 point on a circle, they can't be collinear. The 3 points on a circle cannot lie on a line. So the collinear, when they are collinear, they are given lie on a circle. It's not possible. So it's a wrong statement. And if you want to try to understand this like more clearly about the collinear, you can write like this: this is Z2 minus Z3 equal to Z1 minus Z2. That means like you can see this. You can equate the real parts and the imaginary parts. So this is x2 minus, if we call that z1 z2 z3 as x1 y1 x2 y2 x3 y3, x2 minus x1 x2 minus x3 equal to y2, sorry, LH is RH is the real part, x1 minus x2. Similarly, y2 minus y3 equal to what is that, y1 minus y2. So now if you call this as equation 1 and this is equation 2, and the 2 by 1 will gives you y2 minus y3 by x2 minus x3 equal to y1 minus y2 by x1 minus x2. So this is nothing but the slope of line joining the 2 points z2 z3, and this is slope of line joining 2 points z1 and z2. So the slope of z1 z2 and z2 z3 are same, means they are collinear. So you can directly accept from this that they are collinear, or you can just go through with this the explanation and then agree that the Z1, Z2, Z3 are collinear, so that they won't lie in a circle, but they are given that they lie in a circle as a false statement. So it's easy to verify this statement. So you take for every n belongs to n statement, they are given the same thing. So what you can do is you can take I power n common, and it becomes 1 plus I square plus I cube. So the I power n into I square is minus 1, cancel, and I cube is minus I, cancel. 0, I power n into 0, 0. That's true. So it's kind of matrix matching. They are given column B of the 6 options. Column A, they are given A, B, C, D, E, F bits. So for the first bit, it's kind of options, the common options for a group of questions in the column A. So first this one you need to simplify. So I square is minus 1, I power 4 is 1, this is minus 1, this is 1, this is minus 1 again. So I power 20 is I power 20 is I power 4 multiple, it's 1. If you see, the sequence begins with 1 and ends with 1. So 1 minus 1 get cancelled till the end, and you'll remain with 1, the value will be equal to 1. So when it is 1 out of the options present, the purely imaginary, purely real. So purely real should be the correct answer. So it's the second bit. The simplification is easy. You just go for the 4 multiple. 4 multiple is basically the 96. So I power minus 1096 is 1. I power 4 multiple into I power minus 1, which is equal to, basically this is 1 and this is 1 by I. So this is 1 by I. 1 by I is basically I by I square. I square is minus 1, so minus I. So the minus I is purely imaginary. So it's 2. Oh, so it's 1. So conjugate of 1 plus I is 1 minus I. And 1 minus I lies in fourth coordinate, x positive, y negative. So it's fourth. That's it. That's the answer. They're asking that 1 plus 2i by 1 minus I lies in. So if you multiply that and divide with the 1 plus I, numerator is equal to 1 into 1, 1, 1 into I, 2i into 1, 2i, 2i into I, 2i square. So 1 plus I into 1 minus I, 1 plus 1 equal to I square is minus 1. 1 minus 2 is minus 1 plus 3i by 2. So basically x negative and y positive is in the second quadrant. So it belongs to Q2, and that is there in the third bit, column B, third. You can see that the discriminant is negative and ABC are real numbers. When the ABC are real numbers and the discriminant is negative, the roots can occur in conjugate pairs, may occur in the conjugate pairs, because you know that the discriminant is negative. Discriminant is negative, roots are like in the form of A plus, okay, ABC are already used. So alpha plus I beta and alpha minus I beta. So always roots occur in this form only. We call them as conjugate pairs. So the roots may occur in conjugate pairs only. So that is sixth one. So it's matched to sixth one. The conjugate pairs. Discriminant is greater than 0 and is a perfect square. So your roots are like your roots cannot be conjugate pairs and all. Conjugate pairs means it will be a plus ib into a minus ib form. So it's not necessary. It is not necessary. Without that is also it's possible. So xy may not occur in conjugate pairs. That's 5. So just for simplification, to find the value of it, you take I power 4 in common. And this will be I minus I power minus 1 is 1 by I whole divided by 2. I power 4n is I power 4 the whole power n. And this is I square minus 1 by I by 2. I power 4 is 1, 1 power n is 1. I square is minus 1, the minus 1 minus 1 minus 2 by I whole divided by 2, 2 is 2 by 1, can be written as into 1 by 2. 2 to get cancelled. And you can write the minus 1 in the numerator as I square by I, which is equal to I. So the answer is I. The smallest n such that this equation is true is pretty simple actually. You can write 1 plus I the whole square, the whole power n equal to 1 minus I the whole square, the whole power n. So 1 plus I whole square is 2I actually. You can just expand and write also a plus b whole square. 1 and I square get cancelled and you remain with this. Whole power n equal to the minus 2I the whole power n. The 2 power n into I power n equal to the minus 1 power n into 2 power n into I power n. So this 2 power n get cancelled, I power n get cancelled, 1 equal to minus 1 power n. So the least smallest value of n, in the sense smallest positive integral value of n actually, smallest positive integral n they are asking. Positive n belongs to z, that's what they are asking. So that is smallest one is n equal to 2 is the smallest positive integer satisfying the condition. The reciprocal of that is just 1 by 3 plus root 7i. That's the answer. But as we have a tradition of writing the answer in a plus ib form for the complex numbers, you need to do that by 7 minus 3 minus root 7i equal to 3 minus root 7i by 3 square 9 minus 7i square 3 minus root 7i by 9 minus 7 into I square is minus 1. So 3 minus root 7i by 7 plus 9, 16. That's the answer. So the Z1 is in the first quadrant and Z2 is in the first quadrant. They're asking us to find in which quadrant Z1 by Z2 lies. So you just need to do the simplification. Z1 by Z2 equal to root 3 if we take common and 1 plus I, and denominator is root 3 plus I. If you rationalize, multiply the conjugate of the denominator root 3 minus I by root 3 minus I. So the numerator is root 3 into 1 into root 3 is root 3 minus I plus root 3I minus I square. 4 divided by root 3 whole square is 3 plus 1 square is 1. So root 3 by 4 into I square is minus 1 minus 1 is plus 1 plus root 3 plus 1 plus root 3 minus 1 into I. And again, if you observe that both x and y coordinates are positive, so it belongs to the first quadrant again. That's it. Question asked is to calculate the conjugate of this. So if you could simplify this, then you can find the conjugate of it. To simplify, you multiply with the rationalizing factor in the denominator. 5 plus 12y plus root of 5 minus 12y. So root of 5 plus 12y plus root of 5 minus 12y. And it is equal to the numerator is a plus b whole square kind of thing. A square 5 plus 12y plus b square 5 minus 12y plus 2ab, 2 times of root of 5 plus 12y into root of 5 minus 12y, the whole divided by a plus ib into a plus b into a minus b is a square minus b square. 5 plus 12i minus 5 minus 12i, which is equal to the 12i and minus 12i get cancelled. 5 plus 5 is 10 plus 2 times of root of a plus ib into a plus b into a minus b again. So the 5 square plus 12 square by, and this is 5 I get cancelled. 12i plus 12i, 24i, which is equal to, this is 144 plus 25, 169, 13. So 10 plus 13 twos are 26 by 24i, which is equal to 36 by 24. 12 table 3 by 2i, I in the denominator. But what they're asking the conjugate of it. First you need to write this in the a plus ib form. So for that, you can multiply and divide with I. You get minus 3 by 2i. Therefore, the conjugate of it equal to plus 3 by 2i. The question asked is the principal amplitude. Actually, whenever we are finding the argument, that is principal amplitude only. Argument or amplitude, a principal argument or principal amplitude, everything is same. What we are doing, like this lies in the x positive, the y negative in the fourth quadrant. So if you calculate the tan theta equal to y by our formula, y by x formula, the minus 1 by 1 is equal to minus 1. Tan theta equal to minus 1 will happen in second quadrant as well as the fourth quadrant. But because this lies in the fourth quadrant, you can write the theta equal to minus pi by 4. So hence the principal amplitude is minus pi by 4. That's all. Or else you have that converting into polar form formula. So mod r, the r equal to mod z equal to r equal to root of 1 square plus 1 square, which is equal to root 2. And the cos theta plus I sin theta, compare with that, cos theta equal to y by what is it, x by r, and sin theta equal to y by r. So this is cos theta equal to x is 1 by root 2, and then sin theta equal to y minus 1 by root 2. So cos positive, sin negative happens only in the fourth quadrant. So minus sin pi by 4, and because it's a fourth quadrant, push the minus inside, the sign of minus pi by 4, and get the minus pi by 4. Either of the methods are fine. Like, you just need to get the final answer. They're asking us to find the polar form of this. So I power 25 into 3 is 75 equal to I power 3 multiple we need. So the 72 into I cube, which is equal to I power 72 is 1, and I cube is minus I. And the minus I, we need to write the polar form 0 plus I into minus 1. So cos of minus pi by 2 plus I sine minus pi by 2. So the polar form of that is this, that's all. So the locus of z satisfying this condition. So the amplitude of z is x plus I, if you write x minus 2 plus I into y minus 3. The amplitude of this is equal to pi by 4. And then, so that means tan pi by 4 equal to y coordinate by x coordinate, y minus 3 by x minus 2. So the tan pi by 4 is 1, y minus 3 by x minus 2 equal to 1. That implies y minus 3 equal to x minus 2. So the x minus y plus 1 equal to 0. And that's a locus, it's a straight line. So they told 1 minus I is the root of this equation and a, b are real numbers. According to the property that we have, 1 plus I also should be a root of this equation. So the sum of the roots minus a equal to 1 plus I plus 1 minus I, which is equal to 2. So a equal to minus 2. And the product of the roots b equal to 1 plus I into 1 minus I, which is equal to 1 square plus 1 square, which is equal to 2. So b equal to 2 directly. So a equal to minus 2 and b equal to 2. This is minus 2. That's the answer. So if you see this alternate plus minus, this is 1, and this is minus 1. This is 1, this is minus 1. And we don't know this is 1 or minus 1. So because the 2n can be a 4 multiple or non-4 multiple even number. So it's plus or minus 1. So 1 or minus 1. In case of it is 1, the sum is equal to either 1, or in case of minus 1, the sum is 0. The sum is 1 or 0. So when you don't know the value of n, you can't say that whether it is a 1 or 0. So they cannot say should be the answer. So they are given z satisfies mod z plus 1 equal to 1 and z lies in it. So the mod z plus 1 means x plus 1 plus iy equal to 1. So squaring on both sides, you need not write the square root. X plus 1 the whole square plus y square equal to 1. So the z lies on a circle with center minus 1 comma 0 and the radius is 1. That is third option. The question asked is to find the area of the triangle with these three as vertices. If you go for the geometrical meaning of it, you try to locate z x plus iy and then minus iz is y minus x. So y is the x coordinate and then minus x is the y coordinate. Basically iz means it is a rotation of that. One of the previous problems we saw, if you multiply with I, it will be rotated by 90 degrees. And if you multiply with minus later on, it will be reflected to origin. So then it will come like this. So these two are of same magnitude. And this is 90 degrees and this is reflection. So this will be 90 degrees. So this will be the minus Iz and the sum of Z and Iz. Z is here and Iz is here. The sum is basically along this. The sum is along the diagonal of this. Z plus Iz, not minus Iz. No? So this is Iz. Z plus Iz is like this along this. So Z plus Iz, if we calculate, Iz is I minus y plus Ix. So if you add these two, x minus y plus I into x plus y. Yeah, this is what these. And they want the area of this triangle. This triangle area they want. So they can use the area of the triangle formula. So it's just the calculation. If you take the z equal to x plus iy and you get minus iz as y and minus x, and z plus iz as x minus y plus I x plus y, and you have the area of the triangle formula. In that, substitute the 3 points and simplify, you get this. So the equation represents this line as a circular parabola hyperbola. If you see this z minus of minus 1 plus I. So this represents actually the distance of z from this fixed point. And this is z minus of 1 minus I. And the distance of z from this fixed point. So the two fixed points are there. Z is such that the distance from the first point is same as the distance from the second point. So that's what the z, right? So z lies on a line. If you simplify, if you substitute z equal to x plus iy and simplify also, you get a line equation. But when you know that it is going to be a line, and the line equation is not asked, just ask that whether it is a line, a circular, parabola, hyperbola. You can directly pick that that's the line. So the number of solutions of z square plus mod z square equal to 0 means let z equal to x plus iy and try to solve it algebraically. Z square is x plus iy the whole square plus mod z square is just x square plus y square equal to 0. If you simplify this, it is x square plus I square y square is minus y square plus 2ixy plus x square plus y square equal to 0. So the 2x square plus 2xyi equal to 0. So then x square equal to 0 and 2xy equal to 0. Both should happen. So x square equal to 0 will happen only when x equal to 0. So when x equal to 0 and 2xy equal to 0 for any y value, that means you take any complex number such that the y value is imaginary. This will be true. If you want, you can check. Like suppose z equal to 3i, if you take x should be 0 and y can be any real number. Then z square equal to 3i the whole square equal to minus 9. And mod z square equal to mod z is 3 and 3 square equal to 9. The sum is 0. Not only for 3i, you take any purely imaginary number that will be satisfied by this. So the number of solutions is infinite. To get the amplitude of this complex number, you need to convert this into a plus ib form. For that, you have a different ways of doing it. You can write the sine pi by 5 as 2 sine pi by 10 cos pi by 10. Sine a formula 2 sine a by 2 cos a by 2. And 1 minus cos a is 2 sine square pi by 10. And you can take the 2 sine pi by 10 common. That would be the modulus, and cos pi by 10 plus I sine pi by 10. So cos pi by 10 plus I sine pi by 10 or cos theta plus I sine theta. So the amplitude equal to pi by 10. That's the answer.